Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad, India. In this session, we are going to study about the definitions and terminologies related to the module 3, that is friction. So let us discuss what is friction. Friction occurs when two bodies are in contact. When two bodies are in contact and an effort to move one body or another, one body over the other is resisted. This resistance is known as, there is a resistance to motion is called as friction. How to quantify this friction? The friction is quantified in terms of a factor, that is R coefficient, that is known as coefficient of friction. So here, what is the coefficient of friction? A coefficient of friction is a value or is a quantity of the friction, how much between the two bodies. Now the coefficient of friction, it shows when this value will be occurred between two things. One is the force of the friction and normal reaction. Now the force of a friction, that is the coefficient of friction, is denoted by mu. This mu equal to the force of a friction, that is F by the normal reaction R. Mu equal to F by R. This coefficient of friction denotes or gives the relationship between F and R, where F is the friction force, and what about R is the normal reaction. We are going to study here further in definitions what is F, what is R, what is the unit of a mu. Mu coefficient, it is unitless. It is unitless, no unit for this coefficient of friction. But it is certain factor is there. If the factor is proportional to, here it is proportional to F. F is actually when it will occur this coefficient of friction. F is proportional to R, or R is proportional to the friction force F. Then F by R is known as the constant of proportionality. This constant of proportionality is known as the coefficient of friction. Okay, our friction factor, here the coefficient of friction. The next, there are various types of frictions are there. One is static friction, another one is dynamic friction. Now, there is another term is known as the dry friction. What is the dry friction? Here, that this dry friction occurs between the dry solid surfaces. The friction that exists between perfectly cleaned and dry solid surfaces is called dry friction. Okay, and the next one is fluid friction. Here, fluid friction means this friction occurs in fluid. Okay, that is one meaning. Another one is that this fluid friction takes place in the case of between the thin layers and the solid surface. Suppose the thick layer of oil lubricant is introduced between two surfaces. The friction between the surfaces are separated. The friction between the surfaces are separated by a film of lubricant is known as the fluid lubrication or fluid friction, not fluid friction. What are the applications of this fluid friction? This fluid friction, in order to reduce the friction, we will apply the fluid. Okay, this fluid effect, the value of the fluid friction is less than the value of the dry friction value. In the dry friction, it is between two dry surfaces, clean surfaces, where it will happen. There is no fluid in that. Okay, this is a dry friction value. In order to reduce the dry friction, reduce the value of the dry friction, we apply the thin lubricant or thin layer of the thick layer of the oil lubricant. We are going to use it. Then what will happen? The dry friction is converted to the fluid friction. The value of the fluid friction is lower than the value of dry friction. This concept comes in the case of the fluid mechanics, where fluid mechanics, here we'll study what will happen. Fluid friction, they don't here the coefficient of viscosity, the dynamic viscosity. The dynamic viscosity affects this fluid friction affects the dynamic viscosity, or dynamic viscosity, the viscosity will be affected by the coefficient of the friction. So when friction increases, when friction is high, the viscosity will be reduced. When friction is low, the viscosity is high. That's what there is a connection between there. The shear stress is directly proportional to the velocity gradient du by dy. Then tau, the shear stress, equal to mu times du by dy. This mu is known as the coefficient of dynamic viscosity. So this coefficient of dynamic viscosity is mu here. Here we denoted this mu with the coefficient of friction. But this friction affects, this coefficient of viscosity affects the friction value. When the factor of friction value is high, then what will happen? Viscosity, viscosity will be reduced, dynamic viscosity will be reduced. Here, this mu is coefficient of dynamic viscosity. So, temperature also affects, okay, because of the friction between the layers, what will happen? Temperature rises. If the friction is high, the friction is proportional to the temperature, and temperature is high, is inversely proportional to the mu, a dynamic coefficient of dynamic viscosity. Okay, another one, the term, there is a different subject. This is related to fluid mechanics. The point is that in order to mention how the fluid friction affects the temperature and temperature affects the viscosity, it is connected. Now here the next term is called, what is here? Non-viscous friction. What is a non-viscous friction? The thin layer of lubricant is allowed to prevent the direct contact between the surfaces and reduces the friction. This is the non-viscous friction. The friction that exists between the surfaces is known as the non-viscous fluid friction, non-viscous friction. Now, the key term is that thin layer here in the case of non-viscous, whereas in the case of the fluid friction, there is the thick layer. Okay. So, in the case of what is the application of this fluid friction and non-viscous friction occurs when the bearings are there, or journal bearings. Okay, if there is a shaft, the shaft is rotated between the stuff of the journal bearing category. Here, the shaft is rotated. Here, there is a thin layer. It is outside surface, here between, very thin layer. Here we'll use the thick layer or the fluid lubricant fuel. When it is rotating here, this shaft. Okay, this fluid friction takes place when thick layer of the lubricant is introduced between two surfaces, and non-viscous friction takes place when thin layer of the lubricant is allowed to prevent the direct contact between surfaces and thus reduce the friction. Next important term is known as the limiting friction. Okay, what is the limiting friction means? Here, the definition was mentioned here, the maximum frictional force that can be, the maximum friction that can be generated between two static surfaces in contact with each other is called as limiting friction. So the limiting friction means, suppose the best example for limiting friction is, if there is a table, okay, on the table, if you keep a load, this is W. When the load is applied here, you are going to apply a force in this direction. You apply a force, the value of F1 with some quantity. The weight doesn't move. There is no motion. If we increase F1 value, this F1 value is increased, then there is a limit. At that limit, this W tends to move in this direction. That the friction at that limited force is known as the limiting friction value. That is the limiting friction. Okay, at that moment, after that, it starts moving with constant load. With that, constantly it moves. But there is a limit. That limit, the body tends to move when you apply the force. The value of that, what is the direction of the friction force? The direction of the friction force is opposite to the direction of the motion of the body. So the limiting value, the value at which the body tends to move by the application of the force, that limiting value is known as the limiting friction. So this limiting friction is the maximum value after the body is in kinematic in motion condition, that is in dynamic condition. Okay, up to that place it is in static condition. So when F1 is applied, still it is no motion. That means the friction is between the two surfaces is known as the static friction. When F is increased after the limiting friction value, the body is under motion. At that moment, the friction occurs under the motion of the body between the two surfaces is known as the kinetic friction. Okay, it is in dynamic friction. Now there is static friction and it is dynamic friction. Alright. Now, what is the angle of friction? This angle, it is the angle of the plane to the horizontal when a body placed in plane will just to start the slide. This angle of friction related to the term for inclined plane. Suppose there is a plane. Okay, this is initial position of this plane is horizontal, you kept. Then you kept the body W. When you change the angle, this is the angle, this body is going to slide down weight. If you increase the angle, suppose there is a weight here on the horizontal plane. Now you slowly change the angle position. The angle at which the angle of the plane at which the body starts sliding down, the weight starts sliding down, that angle is known as the angle of friction. That is what the meaning of angle of friction is. Then what is the meaning of limiting friction? It is in horizontal plane. The limiting friction is related to, the limiting friction, the body, the maximum friction that can be generated between two static surfaces in contact with each other is called limiting friction. Whereas angular friction, it is the angle of the plane to the horizontal when your body placed on the body will just start to slide down. That angle is known as angular friction. This angular friction is denoted with alpha. Okay. Now, what is the angle of repose? The next definition. Angle of repose is defined as the minimum angle of inclined plane which causes an object to slide down the plane. Okay, this is known as the angle of repose. The minimum angle of repose is defined as the minimum angle of an inclined plane which causes an object to slide down the plane. That is known as the minimum angle of repose. Now there are various types of frictions as I mentioned. One is the static friction. Types of friction. There are two types. Move on. Static friction. And the next one is dynamic friction. Okay. Again, coming to in the dynamic friction, there are two types are there. Now, what is the meaning or do you understand here? What is the static friction? A static friction occurs between the two static bodies. That means when two rest bodies or when the bodies are in rest, the friction occurs between those two bodies is known as the static friction. So in static friction, the force applied to the body is not sufficient to move the body. And then the friction act on the body is called static friction. What is that meaning? Here, there is a static body. This body is placed on a plane. Okay, the force applied. Now here, what is the force applied? What is the force? The force self weight of the body is W, which is acting downwards, vertically downwards, passing through the center of gravity of the body. So there will be a reaction which comes equal and opposite. That is known as the normal reaction. Now here, between the contact surfaces, here the body is in static condition on the static plane. Then what will happen? The friction occurs. This type of bodies is known as static friction. Okay. Now, when friction occurs, suppose here, when body is having under motion, the body is under motion, it is moving, it is moving and going on. The friction is under motion, that is known as the kinetic friction. So the friction acting on your body, which is actually in motion, is called kinetic friction. Which is actually in motion is called as kinetic friction. Now, here the weight, the body is acting here. The figure 1, you consider the body is in static condition, it is on static plane. That's why it is a static friction. The second figure, the body is under moving condition, motion. There is a friction is acting between the two surfaces. Here one body is stable, another body is under motion. So the friction between these two is known as the kinetic friction. Suppose, what is the ladder friction? And one more term is the wedge friction also. Based on the situation, based on the things. Here the ladder, there is a ladder between, the ladder is slided on the wall. The ladder kept, if you see the view, it is on the wall. There is a friction between this contact between the ladder and the vertical wall and the ladder and the horizontal surfaces. This friction is known as the ladder friction. Here the ladder looks in this condition. Here the ladder will be, strings will be there. These strings are keeping and sliding on the wall such a way that you can paint on the walls, or you can fix the bulbs and all. So the ladder between, the friction between the ladder prevailing, the friction prevailing between the contact point of ladder, legs and floor and wall. This is the floor and here it is the wall. So the friction occurring between the ladder and the floor and the ladder, ladder and the wall is known as the ladder friction. Okay. The next terminology is known as the wedge friction. So again, the friction prevailing between the contact surfaces of any type of wedge-shaped objects and other bodies is known as wedge friction. We will study what is the wedges shapes will be like that. This is one wedge. Okay, and if you are keeping another wedge, this is a wedge-shaped objects. And there is a, here if we keep it, there is a wedge between, what is exactly I will draw here. This is the wedge body. Okay, and this is also another wedge. This is a wedge shaped bodies. So the friction prevailing between the wedge shaped objects and the surfaces, the vertical surface and horizontal, this is known as the wedge friction. Okay, and I already explained what is the dry friction before, and the coefficient of friction also. Coefficient of friction, the ratio of the limiting force of the friction to the normal reaction between the two bodies in contact is called as coefficient of friction. Now the point is that, very important, we are going to discuss about applications of the friction, certain applications in daily life. Now here, this static friction occurs, okay, when there is two contact, when the person is sitting on a table, okay, static friction between the, when it is in static condition, the friction prevails between two static bodies is known as the static friction. Okay, if the friction prevails between the two motion, one body is under motion, another body is under static condition, then it is known as the kinetic friction. If the friction prevails between the edges of the ladder and the floor and the wall is known as the ladder friction. If the friction prevails between the wedges and the floor and the wall is known as the wedge friction. And one more important is that there is another types of frictions also there. What is the friction? When the aeroplane moves in air, that is the friction due to air between the fluid, that is also known as the fluid friction. When the person is swimming in the water, it is known as the fluid friction. It comes under the category of the fluid friction. Okay, there are some dangerous due to friction also there. Okay, what is the evil? That is the evil is the word. What is the evil? Friction causes evils. Friction is evil. How the friction is evil? And friction is also non-evil. The friction is evil. In forest fire, the forest fire takes place because of when two bamboos are rubbing, because of the rubbing nature, it causes the fire, catches the whole forest, it will be fired. That means what? In forest fire causes because of the friction. So friction acts as evil. Friction also having the positive shade, friction also having the negative. The friction because of the catching, fire catches, in forest fire takes place because of the friction between the two bamboos or two trees, or between friction prevails in forest and catches the whole forest in under fire. Fire catches the fire, the whole forest will be under fire completely. That is what this friction is evil. Now one more examples in day-to-day life. The person who is sitting, the person who is mopping on the floor, the particles will be separated completely from the floor. It is due to friction. So friction is highly required for cleaning purposes, for finding purposes, for moving motion. If the person is able to walk on the floor, is going to move front because of the friction. If the friction is not there, if the friction becomes zero, what will happen? If the coefficient of friction is zero, then what will be taking place? Slipping takes place. When friction is there, slipping. This friction becomes, slipping takes place when friction becomes zero. When you pour the oil on the floor, what will happen? The friction tends to become zero, closer to zero. There is a slipping. There is no motion, positive moving. So in order to reduce the friction, we have to use lubrication oils. So at the same time, the friction is also because friction gives the temperature rising. So minimize the temperature, we have to use the oils, lubricating oils, thin layer of oils, lubricating oils between the two rotating components to reduce the friction, coefficient of friction. Now, there is one more thing, certain terminology we have studied, and here what we are going to study, in order to find out the coefficient of friction, we use the expression. That expression is mu equal to F by R. This F is known as the friction force, where R is the normal reaction. This ratio between the friction force and normal reaction gives the coefficient of friction, mu equal to F by R. Now one more term, what is that? Is here, this mu equal to F by R. This is for simple expression for calculating the coefficient of friction. But here what to do? One more thing, the concepts of mechanics, equilibrium conditions we are going to use. When the force is horizontal, it's okay, it's parallel or vertical. When there is inclined force is there, that inclined force, when the force is applied with some inclination, the angle of theta, it is F. Okay, this inclined force is resolved into two components. Okay, resolution of components will use, that is F cos theta horizontal, another one is F sin theta is the vertical components. We have to resolve this inclined force into two, that is F cos theta and F sin theta, and we use two equilibrium conditions. What are the two equilibrium conditions are? The equilibrium conditions are sigma Fh equal to 0, another one is sigma Fv equal to 0. What is sigma Fs equal to 0? Sigma Fs, that is algebraic sum of all horizontal forces, equal to 0, and sigma Fv equal to 0, that means algebraic sum of all vertical forces equal to 0. Okay, by using these two components, we are going to calculate the unknown, either F or applied force or normal reaction, or the coefficient of friction can be calculated by using these concepts. Okay, and here, if suppose, example, if we consider there is a weight on a body here on inclined plane, it is on inclined plane, they are having angle of inclination, that is alpha. So what to do? We have to resolve this weight acts vertically downwards. Whatever normal reaction, the normal reaction is normal to the surface, normal to the plane. So the angle between, we have to, this weight acts downwards, this is the normal reaction. We have to resolve these components into horizontal and vertical, okay, or along the plane and normal to the plane, and apply and find out the equations. Those are known as equilibrium equations. Now here, but this normal reaction, what is the normal reaction? Normal reaction means it acts to the weight normal to the plane of the body. There is a reaction. Normal reaction is the reaction force which acts normal to the plane and which is in equal to the action force. Suppose if we consider the weight, this is the weight of the body. This weight acts vertically downwards, passing through the CG. Whatever normal reaction, the equal to the weight, there will be a reaction force that acts. This is the normal reaction, which also passes through the center of gravity point of the body, CZ. Now, here the W equal to this normal reaction R equal to W. That means weight equal to the normal reaction. So when there is the equal, normal reaction is the reaction force which is in equal to the weight normal to the plane. This is the plane. For this, what is the angle between the plane and direction of the normal reaction? This is 90 degree. Normal to the surface, exactly normal, always. If there is inclined plane, this is what? What is the angle between this plane and normal reaction force? This is 90 degree. Okay, it is 90. Whatever the angle may be, alpha here, with normal reaction is always acts normal to the surface of the body, or normal to the surface of the plane. Okay, so by using these concepts, we will find out the coefficient of friction, and also we are going to find out a normal reaction. Whatever unknown is going to be calculated, which can be calculated by using equilibrium conditions and the concepts of the derived expression, that is the relation between the friction force and normal reaction, that is mu equal to F by R. Okay, one more term. Yes, what is the loss of friction? We are going to study more in detail in the section. What is the loss of friction? What is the loss of kinematic friction? What is the loss of static friction? So here the coefficient of friction is not dependent upon how or what factors it depends. Okay, coefficient of friction is mu equal to F by R. This mu equal to F by R, coefficient of friction, is depends upon friction force and normal reaction. Okay, here the coefficient of friction, as I mentioned here, dependent, and it is independent on what type of parameters. So there is no area. Here the area, maybe we are not going to consider the what is the area of the section of this body when it is on the plane. What is the area of the contact? What is the area of the section? What is the area of the plane? What is the area of the inclined plane and area of horizontal plane? And what are the factors? What are the dependent factors of the coefficient of friction, and what is the independent factors? What are the independent factors of independent coefficient of factors of coefficient of friction. So these are the things we will study in the next session. All right. Now in this session only we studied, mainly focused on what are the definitions and terminologies of a coefficient related to the friction. Okay, concepts of the friction. Okay, and one more session is there. What are the applications? There are various applications of the friction. What is the importance of the friction in day-to-day life, and what is the important role of the friction in technical field, and naturally how the coefficient of friction is the part of our life. We can see it, but we are feeling it, but we are not recognizing this coefficient of friction. So to understand the concept of friction, in the next session we'll study what are the applications of the friction. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.